Hey there, everyone. Ryan Schul at Straight Data Science. So today I want to show you this project I just worked on. This is for anomaly detection using embeddings and isolation forests. And we're going to use Python and the Jupyter Notebook, of course. I'll share all this code with you guys, just like I do with all the other things that I do. So doing anomaly detection with embeddings and using isolation forest and incorporating it all together can help us uncover unexpected, rare, or risky patterns that exist in our data sets that we are not aware of. We don't know about these things. There's too much information sometimes. Companies can have thousands of files, maybe even hundreds of thousands of files, right? It can be saved on network drives. It can be saved on GCP, AWS, Azure. We can have all kinds of Word files. We can have thousands, tens of thousands of Word files, Excel files, data in databases, data in PDFs, data in text files. I'm going to show you an example of reading a text file today, right? So the sources of the data can be very disparate. It can be anything. It can be all over the place. But the goal is to find red flags of potential disasters or pitfalls and detect some type of inconsistency in the data or somehow prevent expensive failures. I'll tell you a true story. I was working for a renewable energy company about a year and a half ago, and this was just before I came on board. I heard about it like one of the first days I was there, so I missed the opportunity. But if I was there, I could have said, "Hey, we could use this process to analyze data and discover if there's a potential threat or some type of pitfall for the business." Long story short, they had drones flying around the solar farm. The drones were surveying the property, and the drone would produce a report. It used AI to scan the entire solar farm and produce a report. So the report comes out. It's about 1,000 pages. They put it into a PDF, goes to some guy or maybe a couple of people, maybe a team. I don't know. But the report kind of just sat there. Nobody looked at it. But there was a very, very, very important paragraph in the report. The drone detected a potential threat of a fire. There was some type of inconsistency in the structure of the solar panels. And then the drone said, "I think there's going to be a fire here very soon. Somebody should look into it," right? So the threat was there. It was detected, but no human being got that message. It was just too much information. A couple of days later, fire happened and burned down the solar farm, cost $1 million in damage, right? So that's the type of threat or potential disaster we are trying to prevent here. We want to look at outliers. We want to look at inconsistencies and something that is in the data. It's already embedded in the data, and it's giving us a message. We want to expose that and interpret that and make intelligent, informed decisions based on that, okay? So I'm going to get my data from these SEC filings. So SEC is short for Securities and Exchange Commission. Any publicly traded company has to submit their financial reports to the SEC, either quarterly or annually. There's two types, is both quarterly and annually, right? Like 10Q, 10K. So these are the 10Ks I'm looking at right here. So it's going to be pretty comprehensive. This is all the financial information about Apple. I'm going to put it into this folder right here. Has my name, Ryan Schul, SEC filings, Apple, and 10K. So I'm going to download the data. This is just a sample. Now, this is very practical and very useful, I think, but realistically, you're going to do this on your own data set, right? Like I said, you're going to have something in AWS or GCP or maybe a network drive. You want to analyze these files about your business, about your company, so you know what's going on, right? Like if nobody knows the solar farm is going to burn down, then there's nothing you can do about it. But if that is information that's embedded in your data somewhere, you want to have access to that. You want to bubble that up and expose that and see what the heck is going on so you can get that information and make an intelligent, informed decision. Let me run this code, Control Enter to run. You can see we download 5 files after 2020. So this has data from 2020 to 2024. The 2025 stuff hasn't been submitted yet, and it's May 11th, 2025 right now. So it's probably, I have to look and see when the 10Ks get filed for these guys. I don't even know. Maybe September, maybe December 31st. They always have different schedules. It can be anytime. Okay, so the code is running. I put in a progress bar here because it takes a little while for the code to run, but let me explain what's going on here as it goes. So everything gets dumped into this folder. Again, you have to point this to your network drive, wherever your files are or your team's files are. You'd have to repoint that, and that is literally it. That's the only thing you're going to have to change there. That's the only variable for you. So that is pointing to right here. Again, this is the source of my data. Ryan, SEC filings, Apple 10K, right? So you would update that thing right there. And this is the model that I picked. So where did I put it now? Sorry. This is all mini LM, so small large language model, L6, I'm not sure what that is, version 2, and that comes from over here, okay? So if you look over here, I'm filtering for finance. These are all the finance pre-trained models. So if you want to do some type of financial analysis, you would train the model on financial topics, financial terminology, financial, it's going to be some kind of financial terms that the model will interpret and learn about, and then it can make recommendations when you ask it questions, right? I'm just filtering for finance. If I take off the filter, I see 1,143. With no filter applied, you can see 1.6 million models. So it's pretty comprehensive, guys. You have a lot of models here. You'd have to filter for the appropriate pre-trained model. And again, this pre-trained is not pre-trained. If you want to train it yourself in your own data, you can do that. If you want to use a pre-trained model, you can do that. There's two styles. There's two flavors of models. Let me see what the progress is. Okay, so it's kicked off at 0%. I put in a progress bar that comes from here. Okay, that's my progress bar. So it does take a few minutes. I want to see the progress as it moves. I want to see how things are aligning and like working out over here. So I put in a progress bar so I can see and determine that the code isn't just stuck or it's just spinning or something like that, because it does take a few minutes to finish off, right? But again, like we're going into this path right here. That's where I saved all the data. You would change that to your system and you would have this. Like I have full submission.txt because all these files are named that over these 5 years, right? So we have 2020 up to 2024. That's the most recent. And if you look close, full submission.txt, that's what we're looking for. But you can just make this open-ended. If you want all the text files, you can just search for all the text files, all the Word documents, you can do that. If you search for everything in your network drive, that would probably take a while for the model to learn everything and to make recommendations. I would suggest doing it in chunks of data, because that's how these models learn best, and that's not going to trip over itself, and it's not going to take days and days and days, right? You can do this chunk today and this chunk tomorrow and this other one the day after that. And if you think about it, that's how humans learn too. You don't take 5,000 pages of data and dump it on a person and say, hey, go learn this and tell me what you think. No, you would read like paragraph by paragraph, go step by step, right, and internalize it and digest it and understand what's going on. The model has to do the same thing. You can't just take everything in the world and just do a huge dump and the model's going to figure it out. No, it doesn't work like that, right? So these are the file names. Again, you can make it more generic if you want to look at all the text files in a folder, and this is where the files sit. And again, we're looking at these chunks of data. Here's my progress bar. This is the model, and I will share all this data for you, okay? And I'm looking for all the words, and this is what's it called? Not standard. Well, I'm having a temporary memory loss. Non-standard, non-standardized data, non-normalized. I think essentially that's it. It's just a body of text, right? That's where we're studying. So normalized data or structured data. That's what I was looking for. So this is not structured data. Structured data would be columns and rows in Excel files, or columns and rows in the database. That's structured data. This is not structured data, right? So we have to handle it a little bit different. We have to take all this stuff and join everything together and comprehensively just blend everything from these 5 files into one massive file, and then train the model on this massive file and tell it, I want to see all the outliers, everything that's distinct and different from the rest, and something that stands out. I want to know the risks. I want to know potentially what the red flags are, right? So I'm saying I'm not going to give you specific instructions. I'm not going to tell you look for a potential fire, look for a potential risk. I'm saying just look for something that's different. It stands out from the whole corpus of text. That's called a body of text. Something that's different, something that's an outlier, something that's an anomaly. So you tell me what you come back with. I'm not telling you what to do. You look at everything comprehensively and you tell me what you think of this. Okay, so that's the whole point here. So we're looking at these chunks of data, and by the way, I'm kind of cheating a little bit here because I did this exercise yesterday. It took way too long. So I'm looking at random samples of chunks just to understand like overall holistically what's going on here, right? So I'm just looking at every 10 steps of chunks of data. So it's kind of like a little bit cheap, but I just want to illustrate the point here. If you're doing this in real life, you probably should not use this line to chunk the data. You want to look at everything in your data set. Otherwise, you can miss some of these risks, right? But I'm just showing you some of the 10 risks here, okay? So you can see potentially like how this thing works and what's going on here, okay? So it's almost done, 87% done. I think we're in good shape. Things are coming together here. 93%, looking good, looking good. Okay, and we should have some final results. And again, what are we looking at? Outliers, red flags, and potential for something that's different from the normal consistency of the language in these documents. So the first thing it comes back with, spending could adversely affect the company's business. Many of the company's operations facilities are critical business operations and suppliers to the contract manufacturing. So that sounds like kind of risky language to me. Okay, we have like a core part of the business, critical business operations that are isolated or they're concentrated with suppliers and contract manufacturers. Okay, and the risk of interruption by fire and power shortages and nuclear power plant accidents and other industrial accidents, including terrorist attacks and hostile acts. So I didn't use risk in this whole thing, but it found that. I found that keyword. So that's very impressive, right? It's not like Control F and Microsoft Word. Hey, look for the word risk, look for fire, look for terrorist or hostile attacks. No, I didn't tell it any specifics. It told me what the anomaly was. Now, this is clearly an anomaly. I don't even know what this means. This is some kind of weirdness. So that's why that got picked up. Anomaly in chunk 214 of related services. The fiscal year is 52 or 53 week that ends on the last Saturday of September. Product iPhone, smartphone based on its 100 iOS operating system, October, November. Pro company released iPhone 13, iPhone 13. I think what it's getting here is a series of different numbers, 12, 13, 2011. So this is just different language. It's just different from the rest of the body of text, right? I think that's why that one got picked up. Okay, anomaly sampled from chunk number 396. Discrimination, compensation. Company believes these are strong words. Okay, that's probably why that got picked up. And should enable employers to share the company's success. The company recognizes people are most likely to thrive when they have resources to meet their needs. Okay, so some strong language. I think that's why that got picked up. Next anomaly here, ability to manage risk. So risk comes up again. I never defined risk as a critical word, but it picked it up all by itself. So good job. Risk again. So that got picked up a couple of times. So that's something that we need to like draw attention to, focus on. Health issues and industrial accidents. That sounds bad. That's pretty strong language. I think that's why that got picked up. Depend on the company's ability to obtain components in sufficient quantities and commercially reasonable terms. So that's a risk too, right? If you can't get your inputs because there's some dispute or some small war in the third world country, and you know a lot of iPhone components or the iPhones are assembled in third world countries, right? If there's a local dispute in that territory, Apple has no control over that. That's a risk to their business, right? That's why this is getting picked up. This is an anomaly that we need to be aware of. Okay, the number of state of attorney general filed civil antitrust lawsuits. That sounds bad. That sounds bad to me right there. So that's why that's getting picked up. So just something to be aware of. I'm not saying that's a threat to Apple's operations, but strong language definitely. And to any proportionate vesting of the award for purposes of this award agreement, active service shall include the duration of an approved leave of absence other than personal leave of absence and first 30 days of approval personal leave of absence. Yeah, it's kind of weird. It's just different from the rest of it. This is an anomaly. It's an outlier. It's not consistent with the normal language used in these 10K SEC filings. So here's the takeaway, right? So isolation force works in the following way. It looks at random partitions that have high dimensionally embedded space. So embeddings, again, is converting words to numbers so the computer can interpret that, right? Measuring how quickly the data point is isolated. Is it drawn out from the rest of the group? Is this an outlier? Is this an anomaly? Is this different, right? Is it heterogeneous? That's going to be different. If it's homogeneous, it's going to be all blended together. We're looking at points that are easily separated in this space, right? So we're taking these mathematical representations and looking at how different they are from the rest of the body of text. If that's different, that's your outlier right there, right? And it sees that embeddings of paragraphs is far from the norm. And I made some notes down here. Chunk 36, corrupt or noisy data. 758 and 220 specific legal cases. 214, what's this? Dense structured product naming. Case number 777, which is right here. This is 777. Legal contract vesting structure. And 396, HR policy language. Less common. Okay, 396 is what? Over here, I think. Right here. So less common language, right? So this could be high risk, high critical issues that need to be addressed. They need to be remediated, or the language is just somehow different from the rest of the body of text. That's what this is, right? So we're looking at outliers. So that is anomaly detection using embeddings and isolation forests. Hopefully that was informative and useful and educational, maybe even entertaining too. I don't know how entertaining these things get, but I try to drop knowledge and share my findings when I work on these projects with other people so you can learn and I can learn and we can learn in parallel. So that's it. I'm going to wrap it up here and I will see you guys in the next one. Thanks for your time. Goodbye.